All right, guys, welcome to our next unit, Unit 11. It's all about solving equations that have trigonometric functions in them, things like sine, cosine, tangent, etc. Today we're going to learn how to find the 6 trig values for an angle on the unit circle using the given angle. Next class, we're going to do the opposite of that. I'm going to give you the trig ratio and ask you to find the angle that goes with it. And that's actually the goal of all of Unit 11. That's how you basically solve a trig equation. So what we're learning today is I'm going to give you the angle and you're going to find the trig values. That's a little bit easier. Working backwards requires a little bit of a foundation there, and that's why we're going to start with the easier part today. But the working backwards is really what we're trying to get to, because that's how you solve trig equations. All right, let's go ahead and begin. So first of all, let's remember all of our trig ratios. You guys may recall that I told you about SOHCAHTOA a little while ago, and that just tells you what all of the trig ratios are. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And when you take these fractions here and flip them over, you get the reciprocal trig ratios. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. And so those are our 6 trigonometric ratios we've already learned. Today we're going to learn what those look like on a unit circle. All right, so here we have a unit circle, and what I'm going to do is I'm going to just sketch an angle here real quick. And you guys should do this with me. And we'll put our little theta there to represent our angle. And we end up having a point right here. And that point has coordinates x and y. And the hypotenuse on this, the radius of this unit circle is equal to 1. We've already talked about that. Now, what we're going to do is I'm going to turn this into a right triangle like we did earlier in their last unit. So I'm going to draw a vertical line here and a horizontal line here, and that creates a right triangle with a hypotenuse of 1. And as you guys may also recall, the x value here is just the horizontal distance, how far over we go to get to this point. So the base of my triangle will be the x value, and the height of my triangle will be how high up the point is, which is y. So the height of my triangle is the y value. Okay, so what I'm going to do now is I'm going to find the trig ratios for this particular angle. We're just going to call it theta here. All right, so let's begin with sine. Now, you don't need to write this yet. I'll show you what I want you to write in a minute, but first I just want you to think with me. What is sine of theta? Well, as you guys know, sine of theta is opposite over hypotenuse. So the side that's opposite from theta is the y value, and the hypotenuse is 1. And so opposite over hypotenuse would be y over 1. But y over 1, doesn't that just equal y? So this is what I would like you to write, because we're going to start making a record of this stuff here. Sine of theta equals y. So we have a new statement here, don't we? Sine of theta is always going to give us the y value. So anytime I give you an angle, if you just take the sine of it, you're going to get the y value. Let's repeat that now with cosine. Cosine theta, what is that? Well, cosine theta is the adjacent over the hypotenuse. So that would be x over 1, which means cosine gives us the x value. So let's put that over there as well. We're just going to make a list of all these over here now. Cosine is x. So now this kind of should remind us a little bit of when we talked about polar coordinates. You guys may recall that earlier when we were talking about polar coordinates, we told you that you don't write this, but x is equal to your radius times cosine, right? Well, guess what? My radius is 1, so if you just replace this with a 1, you just get x equals cosine of theta. So we're really just getting the same thing. It just looks a little bit different because my radius is 1. So we have a nice new reality here that basically anytime you want to find the coordinates for a point on the unit circle, all you need is the angle, and you can take the sine and the cosine of that angle to get the x and the y values. Okay? All right, let's go ahead and continue the process. We found sine, we found cosine. Now let's go ahead and find tangent. Tangent of theta is, as you know, opposite over adjacent. So the opposite is y, and the adjacent is x. So what is tangent equal? Tangent is equal to the y coordinate over the x coordinate. Now, we're going to use that for a little bit today, but you're going to find that we actually won't be using this very much at all in the future. We're going to actually, instead of figuring this out every time, we're just going to memorize our tangent values, and we'll get to that a little bit later. But for now, it technically is y over x. All right, well, let's go ahead, now that we've got those, let's go ahead and do the reciprocal ratios now. Now, as you guys know, cosecant is the reciprocal of sine. So if sine is equal to y, then that means that cosecant is equal to 1 over y. It's just the reciprocal of the y value. And likewise, if cosine of theta is equal to x, then secant of theta will be the reciprocal of that, 1 over x. And finally, if tangent of theta is y over x, then cotangent of theta will be x over y. It's just the reciprocal. That's all there is to it. So sine is the y value. Cosine gives me the x value. Tangent is y over x. And then these ones are the reciprocals of those three. So these are the definitions of the 6 trig ratios on the unit circle for the angles that we have here. All right. So basically, we can get all 6 of these from the coordinates on the unit circle. All right. So let's go ahead and do some examples here, okay? So example 1 says, find the value of the 6 trig ratios for each angle below. We're going to find sine, cosine, tangent, cosecant, secant, and cotangent for 30. We're going to do the same thing for this one and for this one. And you'll notice that the middle one looks weird, but that's because I'm giving you the angle in radians, and that's because angles can be in radians or degrees. So you may find that I'm flip-flopping between those two things today a little bit. All right, well, let's go ahead and begin. Let's find the 6 trig ratios here for 30 degrees. You might want to get out your unit circles at this time. Now, I don't want you guys to write this on your unit circles. I want you to put this example in your notes. Remember, we want to keep our unit circle that you guys are updating as you go nice and clean and just having the stuff on there that we need. We don't want to have any other calculations or stuff on there. So make sure you're doing this work on your notes, but you do want to have out your unit circle here as we work. All right, so we want to find the 6 trig ratios for 30 degrees. Well, here's 30 degrees. The first thing we want to take note of is the coordinates. So let's begin here. Let's start with sine. Sine of theta. Well, we just got through saying that sine of theta is the y value. So what's the y value of that coordinate? It's 1/2. So while we're on that, let's go ahead and find cosecant, because cosecant is the reciprocal of sine. So what's the reciprocal of 1/2? Well, that would be 2 over 1. But just so you guys know, we don't need to put 2 over 1. We can just put 2, right? When you have a 1 on the top, you have to leave it there. But if there's a 1 on the bottom, you don't need it. So sine of theta is 1/2, and cosecant is 2. Let's do cosine next. Cosine is just the x value. So what's the x value there? It's radical 3 over 2. So there's my answer. So since we just did cosine, let's do the reciprocal of cosine. The reciprocal of cosine is the secant one. So secant is going to be 2 over radical 3. Now, as you guys know, we don't like having square roots on the bottom, so we need to fix that. I'm going to multiply the top and the bottom by the square root of 3, and that's going to give me 2 radical 3 over 3. So there's my final answer. Now, just because I want my stuff to look neat, I'm going to get rid of my work that I just did, and I'm going to put my final answer there. But if you want to have your work shown so you can remember how you got there, that's fine. So we've got sine and its reciprocal cosecant. We've got cosine and its reciprocal secant. Let's go ahead and do the last pair, tangent of theta. Now, tangent of theta is going to require a little bit of math work, okay? As you guys know, tangent is y over x. So I'm going to make a fraction. I'm going to put the y value on the top, and I'm going to put the x value on the bottom, okay? Now, I'm going to show you two ways to do this. One way is the long way, and the other way is the short way, okay? So let's do the long way first. You don't have to show your work for this like I am. This is just for teaching purposes. You might want to just stick with the short way. And that's because we actually won't even be doing this very long at all, because pretty soon we're just going to memorize all the tangent values. Instead of having to figure it out every time, we're going to memorize those, just like we did everything else on the unit circle. But anyway, back to our problem here. So tangent is y over x. So that's half over the square root of 3 over 2. So we end up with this complex fraction. How do we simplify a complex fraction? Well, here's the long way to do it. You multiply the top and the bottom by whatever the little denominators are. So the little denominators are 2. So I'm going to multiply by 2 here and here. And basically, that cancels those out, and I'm left with this. Okay, so now, from now on, basically, as a shortcut, as long as we're having to figure this out without having it memorized, y over x, just cross off the bottom numbers. Okay, instead, we don't have to show this work of multiplying by 2. Just cross off the bottom numbers. They cancel each other out. Think of it that way. Okay, but I'm still unhappy here because we don't like having a square root on the bottom. So I'm going to multiply the top and the bottom by a square root of 3. Okay, so 1 times the square root of 3 is the square root of 3, and the square root of 3 times the square root of 3 is 3, and there's my final answer there. So tangent is radical 3 over 3. Now let's do cotangent. Cotangent is the reciprocal of that expression. Now we could just start over, and let's go ahead. Yeah, we'll just do it that way. Why not? We could just flip this answer over, or we could just do the whole process again, but do the opposite. Instead of y over x, we could do x over y. Let's do the x over y approach. It's actually going to be faster. So cotangent is the x value over the y value. It's the same thing, it's just that it's flipped now. And instead of just showing my work, I'm just going to cross those 2's off like I told you. And what I'm left with is radical 3 over 1, which is just radical 3. So I'm all done. Okay. And so there you have it. So that's finding the 6 trig ratios for 30. And actually, something that I said I was going to do and I totally forgot was I wanted to put the angle there. I knew I was going to forget to do that. So let me do that now. And you guys should do this too, by the way, for number 1. We want to actually put the angle on there. The angle I was working with was 30. So let's go ahead and write 30 in there. So sine of 30 is a half. Cosecant of 30 is 2. Cosine of 30 is radical 3 over 2. Secant of 30 is 2 radical 3 over 3. Tangent of 30 is radical 3 over 3. And cotangent of 30 is radical 3. So there we have it. Okay? So there's our 6 trig ratios for 30 degrees. Let's go ahead and take a look at our second one. All right, so for number 2, we want to find the angle 3 pi over 4, and that's in radians. So let's go back to our unit circle now. All right, so first of all, let's find 3 pi over 4. Next of all, let's find the coordinates for that point. So my x value is negative radical 2 over 2, and my y value is radical 2 over 2. So let's go ahead and find our 6 trig ratios for that. So let's start by doing sine of the angle 3 pi over 4. Sine is just the y value, and so that would be radical 2 over 2. Let's do the reciprocal of sine. The reciprocal of sine is cosecant. So let's find cosecant of 3 pi over 4. It's going to be the same thing as this one. It's just going to be flipped upside down. But as you know, we don't like having square roots on the bottom. So I'm going to multiply the top and the bottom by a square root of 2. And I'm going to end up with 2 square root of 2 over 2. And then these 2's cancel out. And so, as a final simplified answer, I'm just going to put the square root of 2. All right, let's do cosine. What's cosine of 3 pi over 4? Well, cosine is just the x value. The x value is negative radical 2 over 2. Let's go ahead and do the reciprocal of that, which is secant. So secant of 3 pi over 4 is going to be just flipping this over. Now, we already did that up here, didn't we? When I flipped this over, it just became radical 2, right? Well, the same thing's going to happen on this one. If I flip it over, it's just going to become radical 2 in the end, but it will be negative because flipping it over doesn't make the negative go away. So we basically just get the same answer there, just negative now. Let's go ahead and do tangent. All right. Tangent is y over x. So what's my y value? Well, the y value is radical 2 over 2. So there's my y value. And what's my x value? It's negative radical 2 over 2. Okay. Well, you can cross the bottoms off if you want. But we still have an interesting situation here. We're dividing square root of 2 by square root of 2. Well, anytime you divide a number by itself, you just get 1, don't you? But since there's a negative there, it will end up being negative 1. And so tangent is negative 1. Let's go ahead and do cotangent. Well, cotangent is just the reciprocal of tangent, right? So even if you took these two fractions and flipped them, you're still going to be dividing the same number by itself, and it's still going to come out negative, so you still end up with negative 1. So there's our 6 trig ratios there for the angle 3 pi over 4. Let's go ahead and take a look at one more, and then I'll let you guys practice. All right, let's do 90. 90 degrees. All right, so let's go ahead and find 90 first. There it is. Let's find the coordinates next. There it is. X is 0 and y is 1. So let's begin. Sine of theta, not theta, sorry, we're going to say 90 since we know the angle, we'll actually put it there. Sine of 90 is just the y value, which is 1. Let's do cosecant, the reciprocal of sine. So what's the reciprocal of 1? Well, think of 1 as 1 over 1 as a fraction, right? Well, if you flip that over, guess what you get? You still get 1. And so they're both equal to 1. Let's do cosine. Cosine of 90 is just the x value, which is 0. Let's do the reciprocal of that now. Now, some of you guys might think, oh, well, the reciprocal of 0 is 0 also. Well, that's actually not true. Here's why. Think of this as 0 over 1. If you flip that over, you get 1 over 0. And you can't have 0 in the denominator. So therefore, there is no solution there, and we'll call that undefined. So, in other words, secant of 90 doesn't exist. There's no answer for that. Let's go ahead and take a look at tangent of 90. Now, tangent of 90 is y over x. So y over x puts a 0 in the bottom again. So that's undefined. So tangent doesn't exist either for 90. All right, let's do the reciprocal of tangent. Let's do cotangent. So instead of y over x, it's x over y. Now, when you have 0 on the top, that exists. That just equals 0. And so there's our answer for 90. All right. Let's go ahead and have you guys try a couple of these. All right, guys, so go ahead and pause the video here. Try number 1 and 2, and when you unpause the video, I will have the solution available for you. All right, guys, go ahead and pause the video here and check your answers to see if you got these right and rework them if you didn't get them right. Now, before we go on, I want you guys to know we're going to memorize our tangent values now. So let's look at our next slide here, and I'll show you what I mean. Get out your unit circles, and you'll see that at the bottom of your unit circle, I provided you guys with a tangent unit circle. And the reason for that is because figuring out tangent, first of all, it takes time. And second of all, when we're working backwards, it's really difficult that way. And so basically, it's going to be really helpful to us if we just have a unit circle with the tangent values on there. Now, whether or not you rewrite the angles, all the radians and degrees, that's up to you. On your unit circle, you'll notice at the bottom of the unit circle paper I printed out for you guys earlier this year, there's a little circle, that's the tangent one. You don't need to put the angles on there if you don't want to, but I do want you guys to include these numbers all the way around, okay? So go ahead and write those on there, and this is the next and last part of our unit circle that I'm going to ask you guys to memorize. After that, we will have completely memorized our unit circle and we'll be done with it. So from now on, instead of going through the hassle of trying to figure out what tangent is by doing y over x and trying to figure out what cotangent is by doing x over y, we're just going to look at this thing and we're just going to memorize that, okay? So you might even want to go back to this slide here on your notes now where I told you guys to write this out. You don't have to do this if you don't want to, but I've just found that students keep using this since it's on their paper, and I would really just encourage you guys to not use that anymore because we're just going to memorize it. So I've crossed that off. Same thing with cotangent. I would just cross it off and leave it at that. So cotangent is basically just the reciprocal of tangent. So I don't think I plan on using those. Now you can leave it on there and not cross it off. It's up to you. But from now on, my advice is memorize it, don't calculate it. So let's look at another type of problem. We're going to do the same thing that we just did, but this time we're going to be finding the trig ratios for angles that are greater than 360 or 2 pi or less than 0. So far we've just stayed within the normal unit circle range, but now we're going to step out of that a little bit. So for this example, you're going to want to look at that other handout that I attached to our notes for this lesson, which has these angles drawn out for you on there. So let's go ahead and begin there with number 1. So you'll notice that this angle is bigger than 360, right? So what we're going to do is we're going to rewrite this angle so that it is in the proper range that we're used to. In other words, from 0 to 360. And the way we're going to do that is just by subtracting 360 from it. So go ahead and write down this step here. That's the first step. That's really the only thing that makes these problems different. Also, I'm not asking you to find all 6 trig ratios. I'm only asking you to find 1. Okay, so step 1 is to rewrite this angle by subtracting 360 from it as many times as is necessary until you get the angle to be between 0 and 360. That way we can actually use our unit circle. So here we go. We're going to take 585 and I'm going to subtract 360 from it. Now you can use a calculator if you want to, but I got that. So now I've got 225. That angle is the same thing as 585. They're coterminal angles. So instead of using this big old loop-de-loo here, I'm looking just at this part here that goes from here to here. I got rid of this circle. And now that I'm looking at that, it turns out that it's just going to be 225 degrees. So now let's look at our unit circle and let's find that spot. What are the coordinates on our unit circle for 225? Take a look at your unit circle and find out what the coordinates are there. The coordinates, as you may know, are negative square root of 2 over 2 and negative square root of 2 over 2. Both of them are square root of 2 over 2. Now, tangent is the one that they're asking us to find. So tangent of 585 degrees is the same thing as tangent of 225 degrees, which is y over x, right? But instead of doing that, let's look at our tangent unit circle. Here's 225 degrees, and what does it say the tangent value is? It's 1. Or you could do the y over x if you really want to, but it's just a lot easier if you have that memorized, okay? So let's get back over here. And so the answer here is 1. So we have, what's the first thing? Rewrite the angle by subtracting 360 from your angle as many times as is necessary to get the angle between 0 and 360. Once you've got it between 0 and 360, just find that spot on your unit circle and find the answer. In this case, since it was tangent, I used my tangent unit circle and I got 1 as an answer. All right. Let's go ahead and move on to our next one here, cotangent. All right. Well, I guess maybe we should go back and revise step 1 a little bit. Let me bring that back. Instead of saying just subtracting, we say by subtracting or adding, because in this case we're going to have to add it, and you'll see what I mean in a minute. Okay, so let's go ahead and do this next one here. Cotangent. So we have negative 870 degrees. So I'm going to add 360 to this thing, and let's see what we get. So if I add 360 once, I get 510. Let's add 360 again. Now I get negative 150. I'm getting closer, but I'm still not between 0 and 360. Let's keep going. So you just keep adding 360 until you get an angle that is somewhere between 0 and 360. And now I'm there, 210. All right, so here we go. That's step 1. So cotangent of negative 870 degrees is the same thing as cotangent of 210 degrees. And for that, we're just going to look at our unit circle for tangent. So here's 210 degrees. And this is the tangent value, but we're doing cotangent, so we're going to do the reciprocal of that. Which, as you guys know, that means we don't want to leave the square root on the bottom there. So I'm going to multiply the top and the bottom by the square root of 3. And my final answer will be 3 square root of 3 over 3, which reduces to square root of 3. All done. Okay, so what did we do here? We want to find cotangent of this angle, but I added 360 to this until I ended up with a number that was between 0 and 360. Then I looked at my unit circle, and I found what the tangent value for 210 was. Since this is cotangent, I flipped that tangent value over and simplified my answer. Okay, let's go ahead and take a look at another one here. Notice that we're dealing with radians this time. So as a little note, we can add the following. Since we're dealing with radians, instead of adding and subtracting 360, we're going to be adding or subtracting 2 pi. So here we go. We have 7 pi over 3. You could tell from the picture that it's bigger than a full circle, right? So we need to subtract from that 2 pi. Okay? So we need to get a common denominator for that. So I'm going to multiply the top and the bottom of this one by 3. 7 pi minus 6 pi is 1 pi, so we have 1 pi over 3. And that angle is actually on our unit circle. Okay, so now we're ready to commence with the rest of the problem here. So tangent of 7 pi over 3 is going to give me the same thing as tangent of pi over 3. So look at your tangent unit circle, and what is the tangent value at pi over 3? Hopefully you guys can see it there. It is radical 3. Okay. So let's go ahead and toss a couple of these things your guys' way. All right, go ahead and try these 4 problems, and when you unpause it, you will see the solutions. All right, so for number 4, you should have gotten radical 2 over 2. This angle here, if you're looking for cosine of 15 pi over 4, you would have to subtract 2 pi from that, and if you did, you would end up with cosine of, I believe it's 7 pi over 4. And the cosine value, in other words, the x value at that particular angle is radical 2 over 2. Okay. For this other one here, you'd have to subtract 360, I think 1 and then 2 times at least. And whenever you do that, you're probably going to end up with something about like 240 degrees. And so the x value at 240 degrees is negative half. For this guy, you're going to have to add 360 because the angle is negative. If you were to add 360 to that one time, you're going to end up getting, what would that be? Actually, you have to add it 2 times, I'm sorry. If you added it 2 times, you're going to end up with 30 degrees there. And so the tangent value at 30 degrees, you'd have to look at your tangent unit circle for that, would be radical 3 over 3. All right, let's continue onward. All right, so example 3. Now, these are angles that are not on the unit circle. These are angles that are not on the unit circle. I mean, they're there, but we just don't, they're not recorded on there. Let me show you. So my first angle I wanted to work with was 70, but here's 60, here's 90. 70 is somewhere in between there. So there is a point here, and we could draw a line to represent a 70-degree angle. But we don't know anything about these coordinates right now, right? So what do we do in that case? Well, there's a way. Remember how we said that sine of the angle, goofed up there. Sine of the angle is the y value, and cosine of the angle is the x value. Well, what we could do is we could just use our calculator. I can find cosine of 70 and sine of 70 on my calculator, and that will give me my x value and my y value. Once I know those 2 things, I can go ahead and find all the rest of them. And so that's how we're going to go about doing this problem. So it says find all 6 trig ratios for that angle using your calculator. After that, we're going to state what the coordinates are, and we're going to plot the point on the unit circle just to kind of really wrap our minds around what we're doing. So let's go ahead and find sine and cosine first. Okay, let's begin. So for number 1, the first thing I want to do is I want to find sine of 70. So let's do that. And once again, that's not on my unit circle, so I can't look at my unit circle and just find out what's the y value. So I need to use a calculator for that one. So I'm going to do 70, and then I'm going to push sine. And there it is. And we're just going to go ahead and round it. How far should we round it? Probably to the 3rd decimal place, just to be safe. If I do that, actually, I put 0.940. All right, so there's that one. Let's do cosine. Cosine is just the x value, but we can't look at our unit circle and see what the x value is, so we have to use our calculator again. So I'm going to push 70. And then I'm going to go to trig, and I'm going to push cosine. And there's my answer. It's going to be 0.342. Next, I'm going to go ahead and do tangent. Tangent is on the calculator as well. So we're going to do 70. We're going to find the tangent button and push that. And tangent is 2.747. Now, my calculator is kind of unique here because my calculator has secant, cosecant, and cotangent on it as well. But I'm betting that most of the calculators you guys are going to use don't have that on there. So even though I'm kind of lucky and I really could just push 70 and then find the cosecant button on my calculator, I'm assuming that many of you guys don't have a cosecant or, oops, let me bring my stuff back here. I'm assuming most of you guys don't have a secant or a cosecant or a cotangent button on your calculator. So how do we do it if the calculator, if it's not on our unit circle and we need to use a calculator, but those buttons aren't on our calculator? What do we do? Well, thankfully your calculator does have these three. And once you have these three, you can find the other ones because they're just the reciprocal of these numbers. So for instance, the reciprocal of sine is cosecant, right? So what's the reciprocal of this? Well, just do 1 over that. What's the reciprocal of cosine? That would be secant, right? So that's just going to be the reciprocal of this number. And then finally, cotangent will just be the reciprocal of tangent. Now, we probably shouldn't leave our answers like this. We could actually just use our calculator and simplify them a little bit more, which is what I'm going to do. So let's do this one. 1 divided by 0.940. 1 divided by 0.940 equals. There it is, 1.064. And we're going to continue that with these other two here. Just do 1 divided by 0.342 and 1 divided by 2.742 to get the other. All right, so there's that. Those are the 6 trig ratios. And that's the first part of what they wanted me to do, was to find the 6 trig ratios using the calculator. So how do we do it? You just do sine, cosine, and tangent right on your calculator, and then just divide 1 by each of these numbers to find the reciprocal trig values that go with those. Now, we're still not done with this first question here because it asks us to do something else. It asks us to state the coordinates of the point and then plot that point on the unit circle. So I guess we'll call this part here A. Oh, that's part A. Let's do part B. Part B is pretty straightforward, though. I want the coordinates. The coordinates are the x value and the y value. In other words, the answer we got for cosine is the x value, and the answer we got for sine is the y value. Okay, and then when it comes to part C, if I wanted to plot all that, just so we can kind of get an idea of where it's at. There's 2 ways you could do it. One way is you could just find out where 70 is. You guys know that 70 would be somewhere like right about there, right? So there's that point. 0.3 and 0.9. I'm just going to round them a little bit more because I can't fit it all on there. And that would be good enough. Or, you could actually think, okay, well, if this is 1, where's 0.3? Well, 0.3 might be here and 0.9 might be here. So find where those dots meet. I think that's a little bit harder, but either way is fine with me. So let's go ahead and take a look at our next one. Now, our next one is in radians. And for these ones, it's important to make sure that your calculator is set to radians. So that's a helpful little note there you might want to add into your notes. Make sure your calculator is in degrees if you're doing degrees, and make sure it's in radians if you're using radians. It's a little detail that's easy to miss, but most scientific calculators are preset to degrees. You guys see this here, it says DEG. That means my calculator is doing things in degrees. If we want to do this one though, number 2, we're going to have to change the calculator into radians. And so I'm just going to click that and it's changed to radians. Now different calculators will have that button located in different places and you just kind of have to find it for yourself. But there it is. So now my calculator is set to radians and I'm ready to do the problem. Don't forget though, when we go to student practice, you might have to flip back to degrees. So you have to pay close attention to what your calculator is on. All right, so here we go. We're going to begin by finding sine of 3 pi over 7, cosine of 3 pi over 7, tangent of 3 pi over 7 first. So let's do that. Here we go. So 3 pi, where's my pi button? I guess I'll just put times 3.14 for pi. Some calculators will have that pi button. So 3 pi over 7, so divided by 7. So this is 3 pi over 7. It's just written in decimal form. And now I'm going to do sine. And there's the sine value. It's 0.975. Let's do cosine. So 3 times pi, which is 3.14, divided by 7. 3 pi over 7. There it is again. Now we're going to do the cosine of that. And there's that. So that's going to be 0.223. Okay. And finally, we'll do tangent. So 3 pi over 7. And we're going to do tangent. And I get 4.368. Now, if I want to find the reciprocal ones, cosecant, secant, and cotangent. All I'm going to do is I'm going to take the reciprocal of the numbers they're next to. So cosecant of 3 pi over 7 is going to be the reciprocal of the sine value. So 1 over 0.975. Secant will be the reciprocal of the cosine value. So 1 over 0.223. And then cotangent will be the reciprocal of the tangent value. And then once again, we'll just punch that into our calculator and find all 3 of those values. All right, and so there's those ones. And that's the first part. We also want to state the coordinates. So all of this is part A, right? Just finding the 6 trig ratios. Part B is to state the coordinates. The coordinates are the x value is here. I'll round it to the tens place this time. And the y value is here. So there's my coordinates. And then finally, we can also go ahead and plot that point. Now, there's a couple ways you could do that. Radians are a little bit tougher. We know where degrees are located pretty well, but one thing you could do is you can convert this to degrees by multiplying it by 180 over pi, and that'll give you an idea of where it's located. Or you could just use the coordinates the way that they're given. On the unit circle, this is 1, and up here is 1 as well. And so going over 0.2 would probably be like about here, and going up 0.9 would probably be about here. Where those two are going to meet is probably right about there. It's actually pretty darn close to where the last angle was. So there you guys have it. All right. I'll put the coordinates there too. Well, let's go ahead and have you guys try some of this stuff here. Here we go. All right, guys, so here's 2 for you. Go ahead and pause the video there and give those problems a try. And when you unpause the video, you'll see the solutions. All right, guys, and there are the answers for numbers 1 and 2. So I'd encourage you to check your answers here, pause the video and check it out. But that's it for today. We will see you guys in class, and we'll put some of this stuff to practice. See you then.